Oh, good. Hello. There's quite a few of you, which surprises me. If you were here last year, I told you I was going to talk about C#, then immediately bait and switch to something else. So I'm surprised anyone turned up this time. This is not a bait and switch. I am actually going to talk about TypeScript. I'll apologize in advance. Your conference organizer, Raf, tried to kill me last night with cherry vodka and Jägermeister, and I'm not in a good way this afternoon, so I'll struggle through and do my best, and I hope you'll be sympathetic with me. Who's my audience? Do you guys write TypeScript? Yeah, okay. I mean, I might be teaching grandmother to suck eggs at this point, so I apologize in advance for that too, if that's the case. Raf asked me to do a talk. I gave him a selection of things I was currently doing at work, and he said, do a talk on TypeScript. So I'm doing a talk on TypeScript. It's not, well, I'll get into that. It's fine. So who am I? I'm Rob, and I work for a company called Ideas, and I guess the main thing is that we are quite a fast-moving team. We're one of those companies that do actually push directly to the main branch of our code and release from the main branch of our code, and we just repeatedly just do that all the time. And there's a mascot. Actually, it's quite cool. It's Trinorsk. We have quite an interesting technology stack, and I want to talk about that a little bit because I want you to understand where I'm coming from with my perspective on TypeScript. I don't come from the C# side of things, which I imagine most of you chaps probably do. Are you .NET developers in this room, mostly? Yeah, exactly. So I don't come from that direction, so my perspective is slightly skewed. We actually work in PureScript, which you probably never heard of. If you have, well done. It's basically Haskell, so that's what we write code in every single day. We actually compile that into Erlang, which is so a little more esoteric than you might think, and then we call into a whole pile of Rust to do an actual bit of work, and unfortunately, quite a lot of C as well. We'll ignore the C, we'll pretend it doesn't actually exist. A large part of my time at work is spent adding segfaults in C. Yeah, what an awful life. Anyway, our product looks like that, and we have an SDK that's written in TypeScript, which talks to the media server in gRPC, and then customer code kind of goes here and gets written hopefully in TypeScript, but more commonly in JavaScript, and it's very upsetting when they're using JavaScript because I have to support them, and there's so many bugs caused by the fact they're using JavaScript, it's just upsetting. But anyway, that's what we built. But a year ago, I had a wacky idea. That's me having a wacky idea. He's an awful person, isn't he? What if I created Windows Forms for video workflows, I thought to myself. I set about doing that, which involved writing a lot of JavaScript. So I wrote a drag-and-drop designer in JavaScript over the top of our SDK, and basically had a whole pile of YAML representing workflows, and it's the code behind that in JavaScript sort of drive the actual functionality of a media workflow. And it was an awful idea, and it doesn't look like that anymore because it was a terrible fucking idea. But the drag-and-drop designer thing for video workflows was actually awesome, and everyone really loved it. So it became an actual product. Now, I had a problem with that. I wrote it all in JavaScript. I wrote it all in JavaScript because if you are anything like me, you'll understand, writing JavaScript is fun. You can just throw stuff at the wall and see if it sticks repeatedly. And you can iterate and delete and iterate and delete. And when it's just you working on a project, that's kind of okay. So I had no tests, no types, just a big folder full of JavaScript that had a really cool demo that made everyone go, wow, that's amazing, Rob. Can we sell that as a product? So yes, but now I need to actually write some real code and hopefully hand this over to someone else in the team because I don't want to be stuck being the UI guy. It's just not like, as much as I might bitch and moan about writing C, I actually prefer doing that. So it's what I actually enjoy doing on a day-to-day basis, not writing UIs. So I need an escape plan. And the escape plan, obviously, is to not be a cowboy. It's to try and make the development workflow for the UI look like our development workflow in the rest of our stack. So our development workflow looks like this. You identify a requirement, which obviously easy bit. You make some changes and write some tests. It takes a few minutes. We spent a few hours or maybe a few weeks fighting types. And I'm not exaggerating, but it has sometimes taken a week or two to get things compiling after making sweeping changes. It does happen. It's quite upsetting. And then we ship. Now we fire and forget, and we operate a kind of zero bugs policy on our code bases, and this works out really well for us. Generally, by the time we get to the point where we're shipping code, it will work. Our feared development workflow is what we would have ended up with if I stuck with JavaScript in that project, which was identify a requirement, make changes and tests, ship it, and then iterate on bugs instead of features for the rest of our fucking life, which is like, we've all been there, right? This is just an awful place to be. So how do we avoid that? Well, the first thing is you don't write JavaScript. That's just an awful idea, which is funny because 14 years ago, I'd have said the exact opposite. I loved JavaScript. But no, these are the hallowed tools that we should be using to write any code in JavaScript, i.e. nothing at all. Which, if you're in this room, you've already decided that. You've already made that decision anyway. So basically, you need to turn from being a cowboy into professional. I had this big code base, well, big, 2,000 lines, it's not very big at all. It's now about 20 or 30,000 lines. The first thing was to add a TS config and some ESLint config. And then, as I added code to my project, identify issues in my code, and ask these questions. Could I have prevented that issue with better types? Could it have been invented with an ESLint rule? Or could it have been invented with a test? And this is the order of preference. Like if I can solve it with types, I'll solve it with types. I don't need to have a test if my types assert things for me. I might have tests as well, but I don't need it. If you aren't swearing at a compiler every time you make a change, you need a better compiler. That's generally how I see the world. Maybe not spending weeks fighting type errors in TypeScript, but certainly I want to be told I'm wrong at every turn when I'm making changes. Otherwise, I don't feel confident making changes. I want my compiler to constantly tell me I'm wrong. It's important. I want to push my cognitive load into the types and assertions so I can free the brain up for arguments about other stuff. Gosh, the number of arguments about color schemes and round corners and things, and out that. So anyway, here's some common ESLint rules that we apply. I'm just going to skip past all this stuff quite quickly because you probably have these things implemented. Ban any. I'm sure we all ban any in our code bases, absolutely. Option strict. No unhandled promises. They are the worst. No shadowed variables, ban var, ban unused variables. And again, if you aren't swearing at ESLint every time you make a change, you need a better ESLint configuration. ESLint should be upsetting you every time you write code. Your editor should be screaming at you that your code is terrible, because it probably is. Certainly mine is anyway. When I onboarded other developers onto the project, they all absolutely hated me, because by the time they were on the project, I had all the rules set up, and I'd changed all the code to adhere to the rules, and it was absolutely nightmarish writing code in the project. But they've stuck with it, because I am the ruler of the project, and life is good because we're shipping like we want to. So anyway, code. Let's do code. Let's just jump into the whole code thing. Let's talk about primitive obsession. For some reason, I always bring this up in talks. It's just one of those things. Oh, actually, I was going to show my ESLint setup. Is it actually going to work? Yeah, it does, exactly. So, whatever. Lots of problems with this code. I mean, oh, that's a terrible color scheme, isn't it? Hang on a second. Let's go with something. That'll do. It's still horrible, but you can probably read it slightly better, can't you? This is Helix, by the way, editor. It's really cool. I've started using it about 3 months ago, and yeah, it's actually quite nifty. So anyway, horrible code. My file name doesn't have a type, so I'll stick that in as a string or whatever, and that's never used. Fair enough, I'll use it. I got told, but I'm not handling the promise. I need to do that as well, and off we go to all the rest of it, right? Standard stuff. Anyway, moving on. Boring. Primitive obsession. We all do this all the bloody time, and in C# you kind of have no option but to do this. You can work around it by doing some fun, janky types, and people do, but it's horrible. In TypeScript, there are nice answers for things like this. So obviously the things wrong with this code is like all these things are strings or numbers or whatever, right? And there's no reason for them to be those things. They could be any value whatsoever, and they could be wrong values. So actually, all of these should be locked down to just the values that you actually support. Does anyone know about video stuff in this room, by the way? I've had codecs and things like that. We're vaguely familiar, right? I mean, it assumes knowledge. Like, I thought this is nice. I used my actual domain in my talk because it's something I'm familiar with, and I'm forgetting that people might not actually be familiar with the domain. Anyway, normally what you do is you've got some codec configuration, and you have to turn that into something down the stream. So it's quite tempting to do things like this, right? assign some type aliases, and build something that looks like this. This is rubbish. It doesn't actually achieve anything whatsoever. Type aliases don't really do very much for you in the world of TypeScript. I can still assign arbitrary values to these things. There's nothing stopping me assigning random things to these values. Generally, just completely worthless, and do that. What we can actually do is, in TypeScript, I really, really like this. It's like, honestly, like I hated TypeScript 10 years ago, and I don't know why I did, because this is remarkably simple, right? I can say that actually type can only be one of these three values, level can only be one of these values, profile and tier can be these values over here, right? And that's kind of nice. It means if I say I want to create a value of this type, that's nice. First and foremost, my editor will automatically insert some valid values for these things because they're in the types, so it can do that for me. That was actually quite nice of it. But more importantly, I get some nice help in my editor for doing these things properly, and I can't assign garbage values to them. Well, it'll be compile error, right? It's not allowed. So that profile, it's not assignable to baseline, main, or high. Good. Okay. Wonderful. And actually, we're going to use this domain repeatedly in this code base, so I'm going to make it even better. There are actually differences between codecs. So I'm going to define each of these as a type in its own right. And I'm going to make a union type down the bottom over. Oh, should have actually commented out this thing over here. There we go. So I can actually further lock these things down and say, if you've got H64, you've got these values, HTVC, these values, AV1, these values, and export a type, which is a union of these things. And that's something you can just do, and it's wonderful. This is like equivalent to an ADT in like Haskell or something like that. And it's so nice TypeScript has that. They keep arguing about adding it to C#, ADTs and such, and the arguments always on the lines of, why do we need that? That's an awful idea. We'll never use it. I'll never use that feature. I'll avoid any code written using that feature. And the GitHub threads are hundreds of pages long and 5 years old. And I don't know why it's controversial, because ADTs are just like the greatest programming construct in any programming language. Absolutely essential to have them. So what this actually means is, if I want to have a value of codec configuration, I have to specify a type, which is my discriminator. And once I've done that, the other values will be locked down to just the values that are supported by that codec. And that's all asserted at the type level, which is, so that, there we go. So I'm going to add baseline, main, or high for H64, even though AV1 over there supports main 8, main 10, and high 10, right? That's kind of awesome. And it's all just automatic in my compiler, and I can't put in wrong values, and it's a nice world to live in. So anyway, primitives, yeet them. I don't want to see string or number absolutely anywhere. I don't want to see type aliases. Just lock down your values, if you can, in your domain to the values you can only actually support. This is very basic stuff, but it's good to start with the basics. So there we go. Right, exhaustive checking. This is another thing that really gets my goat in C# all the time when I'm working in it, which isn't very often, I have to say. I'm just going to make that compile again. Right, what's wrong with this code? Well, we can all see what's wrong with the code. I've got the same domain, so I've got 3 possible types down here, H64, HTVC, and AV1, and the codec configuration of those things. And I've got a switch statement over here where I'm converting my codec into some kind of command line. Now, there's actually something wrong with this. What's wrong with it is that what happens if I add a new codec type to my code base? Right? I've got to add another case. Well, do I? I mean, that's the thing, right? That still compiles, everything's fine. That's awful. That's just a terrible place to be. And now in C#, what you would do is good old, and at least have a runtime error. It's unfortunate. That's because everything in C# boils down to ints when it comes to enums and such, so they never bother doing exhaustive checking on their switch statements, because it could be any value, so you can't do that. Well, in this world, we know it could be any. We know which values it could be, and you can even see, the type of my function here changed when I added the new case, because the compiler is entirely aware there's a drop-through case, and I could be returning undefined. So you see over here, the function is now possible to return undefined. The compiler knows. So the compiler can be told to throw an error, right? I can just throw this in. And I can say, look, if you ever end up in the default thing, assign codec type to the type never. And the compiler is going to say, well, hang on a second, I've reached that code. String is not assignable to never. So hang on a second, what the hell, guy? So if I get rid of this for the end of this thing over here, it'll compile again, quite happily, because that code path can never be reached. The compiler knows it can't be reached. Therefore, that statement's never going to be read. Now, it's still worth having a log or a throw here, because sometimes bad developers like me do drop to JavaScript or call foreign code that return the wrong value completely, and you get a runtime fall through to default, and that's not very good. So it's nice to have a log or a throw there. But in general, I don't want to see case statements without defaults or without a never in them. I just don't want that. So I can go over here, and I can go and add my new case, which is new, obviously. I'll just return empty string for now, and my compile error goes away. That's remarkably useful. I really hope when C# gets ADTs, it will support exhaustive checking. So yes, anyway. Yes, it's a very tiny change to my code, but the type never is there. We should be using it a lot in our code bases if we don't already. Never is really good to assert that this code path's never going to get hit. And if you think a code path's not going to get, you should assign something to never. So there we go. There's the important code. Yes, indeed. Avoid hand waving with partial T. Well, there's a thing. I hate hand waving. Yes. This is quite a common scenario. I'm going to read some codecs off disk. So I'm going to read a file, which is a string just here, and I'm going to parse it. And now I've got an object. I'm going to cast it to a codec configuration array, and I'm going to just go for each of those and print them out. Okay, cool. What's wrong with this code? What's wrong with this code? I'm doing no validation whatsoever. I can't do any validation because this chap here, the types inside here, none of these are nullable whatsoever, right? So what you'd actually do to get around this is not lie. You shouldn't be lying. Lying is a really bad idea. We should be saying, well, actually, this chap's going to return a partial of codec configuration. And I'm going to say, well, actually, this is a partial configuration. My code down here is going to now get very upset because everything has been made undefinable in that type. And we're forced to do validation on that. And then, actually, this still isn't correct because oops. Could do with actually. And then so on and so forth to the actual return value there. So obj as partial. So I imagine most of us have used partial, and we kind of know what this chap's doing. But just in case we don't, if I want to have a value over here of type codec configuration, I need to have properties in there, all assigned and such. Otherwise, I get errors. Right here, start valid type. If I make this chap partial, I need nothing in there whatsoever. It's absolutely fine. I put an underscore in front of it. That's fine. Bloody ESLint warning, telling me all the time unused variables and such. Yes, indeed. So I can have every single field undefined in there. Now, that's kind of interesting because it leads me down the direction of doing parsing and such. So this is the code that we're doing for reading codecs over here, a partial configuration. And down here, instead of just trying to do the two-command line of the actual thing, I'm going to parse my partial code configuration and turn it into a parse result of code configuration. So down here is I have a union type for representing a parse result, which can either be a result with the actual parsed value, so or I've got a failure, which is true with a message. Again, ADTs, just the best thing, any feature in a language. So my validation function is going to say, I'm going to take a partial codec configuration and return a parse result of codec configuration. I'm going to get the type out of this, do a switch statement, and I'm going to have a default block. And the thing is, I can't do a type level default block here because type could be undefined. Right? So how am I going to work around that? Well, obviously, I could just check for undefined over here. Oops. And now the compiler will actually happily tell me that I can do a never in here. However, this is actually quite wordy in its own little way, and there are some cool tricks we can do instead of writing switch statements when building up types like this. And I kind of want to talk about those a little bit. So what we can do, getting the knowledge validation functions, is we can actually create a type from that field inside that type. So codec configuration has a type field in every single thing, and I can assign that type to this here, and that known codex there is just going to have AV1, H64, ATPC in it. I can say a codec validator is something that takes in a partial codec configuration, it returns a parse result, that's good. And then I can export a new type, which is a record of the known codec to the codec validator. And then I can create a list of validators. And if I miss one of them out, I'll get compile error. I'll just get told I'm missing out that error over there. So what I'm doing there is I'm constructing new types from my actual types to push the requirement of having validators existing into type system. I can't add a new codec type without the compiler complaining to me right at the root of the type system. I haven't got to wait until I use it. I haven't got to wait until I add a switch statement. I'll be told straight away, you need to have validator for that. It's just automatic. So using that, obviously it's going to be quite simple. Just in this function here, I'm just going to get rid of that, and I'm going to say if input.type equal undefined, again, just return that error, which I've kept a message around. And I can say const validator equals that's fine. And if I have a validator, again, oops. Hey. Right. Happy days. What have we done? Oh, well, that's not important anyway. I'm too hungover to looking at code. So, oh, that's nice. I'm doing a bit of a light show. That's good. So anyway, don't hand wave ever. Use partial. Use partial aggressively. If you're not sure what you've been given, if you've been given input, use partial. You can pull fields out of types, generate records using those fields, and get a compile error at the very beginning of your code next to the types you're working with, which is just like one of the best patterns ever. You can't even easily do that in my Haskell type languages. The gymnastics you require would be phenomenal. TypeScript's kind of groovy in that way, I have to say. So anyway, there's more we can do with this. If we go and look at the implementation of one of those validation functions, so validating H64, for example, I've got a function here where I'm saying if I've got H64 type over here, then I'm going to validate my levels. I'm going to say, actually, if it's a known value over here, then that's great. And if it's a known value, it's great. And then return a result over here. This code is ghastly. I mean, I don't want to maintain this. This is just horrible. Well, there are tricks for this too. So the problem fundamentally is that my type here has these things in line as just possible values. And there's no way of saying what are the possible values. Well, there's a trick for that. We can make an array of H64 levels, and we can make a new type from that array. And we can say, well, this type here now is just all those values there. And I can use that up here. That's my level, and say, there we go. So I've got my array of possible values. I've got my type, which is only those values, and I'm using it. I can do the same profile. So I can take an array of my profile levels here, baseline, high, and main. I can pull the profile out and say, look, whatever type's in that array there, I want to use that as my profile. And just to prove that it has actually worked, there you go. I'm not allowed to have bad values here. It's actually pulled them out for me, and it knows what's going on. That's just kind of awesome. TypeScript, again, really coming through for us. And because we've now got data representing our types, and we've pulled the types out of the data, I can go and do something like this and say, if level is equal to undefined, or my H64 levels includes level, and that should be a not, or the code's going to end very quickly. I can say, nope, I'm sorry, but it's a failure. And I can delete that code down there. Happy days. And I can do the same with profile as well if I want to, which is good. And delete that. And down here, I can return the value because I've validated that things are actually correct. Now, if I didn't have these checks in place, this would fail because profile could be undefined or any value whatsoever. So, it's actually kind of cool, right? I can make data and pull types out of data and use those types. Generally, in TypeScript, if you want to do something like that, there's a way of doing it, and someone on the internet has described in detail how that works, which is kind of awesome. So, yes, you can create unions from constant arrays and then use those unions as actual types. And if you do that, that gives you some possibilities because you can do things like populate drop-downs from your list of possible values. You can use them for validating correctness, and you can use them for generating documentation as well, because your actual data floating around with possible values and such. You haven't got to parse the types to make that happen. It's a cool trick. Utility types. Well, find out what that is. For types. Yeah, that makes sense. So I've got my H64 codec, once again. I love the H64 codec, it's very useful. And let's say I'm doing some rendering on the client or such. I'm sending a view down to them so they can have some drop-downs and a description of the current configuration and profiles and such. What I could do is make a new codec view type onto which I have a profile and a level and description and possible values we have. And I can render my form by creating a view, by copying out the codec here and render the view. And obviously render view would take that and give you a string using Svelte or React or Angular or whatever everyone's using these days. I have no idea what you're using these days. I still use React because what I know or what I knew 10 years ago. So, I'm sure there are better things. Problem with this is, once again, if I go over here and I add a new thing to my codec, I don't get any feedback for that. My view isn't going to have the bitrate on it automatically, which kind of sucks. So what you can actually do is you can say, well, I want a codec view, and again, I'll just give it this one here now. I'll take the H64 codec. I want to emit the type field from that type, and then add on these other fields over here. And that type there now has bitrate in it automatically, which over here I'm getting an error because my view hasn't got bitrate set. So I can say actually bitrate is equal to codec to bitrate, and now that's going to be copied down automatically. Now, that's kind of useful, except for, gosh, I'm manually doing that now. But again, the compiler's here to help me. Happy days. So what I'm able to do is construct new types from existing types by picking fields out of them or removing fields from them, and then reuse that in such a way that when I change the types, everything gets copied automatically into my view. That's nice. And there's quite a lot of these utility methods floating around if you go and read up about them. They're fascinating things. So you can pick fields, omit fields, you can convert things into awaited promises and such. And if you can think about it, someone's added it. Now, again, 10 years ago, when I first hated TypeScript, these things didn't exist in this way. And it's really a pleasure to come back and see that these things actually are here. So yeah, the only thing better than runtime reflection is compile time reflection. Effectively what that is, right? We've all been clever sausages and written reflection code in C#, right? And built libraries out of that and felt very proud of ourselves. You can do it types in TypeScript and do it at compile time. Absolutely awesome. So yes, reusing some types is actually really useful. Very often you find yourself using someone else's library you can't modify, but they've got piles of records and types in there that are just about the right shape that think you need, but not quite. And you can modify those types, define your own types off of them, and they'll stay up to date with each other forevermore, which is just great, really. Very few languages have that ability in them. It's nice. I do want to briefly mention something that actually we started doing in a lot of places in our code base. The only thing better than code is YAML, right? So there we go. Let's define our h64 as YAML. Why would I do this? There's a very easy answer for it. Are we all using OpenAPI, Swagger, and all that nonsense? Yeah, best thing in the world. We've got APIs coming out the wazoo, and so now we actually define nearly all our types for those APIs in YAML, and we write these YAML documents over here and define our actual values and such, and then we use a library which generates TypeScript types off of them, which is just an awesome thing. So that's what it's generated. It's given me that lovely thing there. That pixelation is absolutely atrocious, but that's largely equivalent to the thing I was manually writing before. And that gives me some advantages. First off, I've already got my YAML, so when it comes to serving my Swagger up to people and alongside my API, I can just give them the YAML, and it's something that works. They can generate their own types off of that in their own language and use it. And then over here, I can import this from over here, and I can say, actually, I'm going to export a type called h64 codec. And that's going to be a type alias for a thing that lives in components under schemas. Oops. Thank you, editor. That was nice of you. Underneath h64 codec. There we go. I'm going to do the same for profile. So, oops. And do the same thing for level. Happy days. And that is now my actual API for use inside my application. So actually, in a lot of our code base these days, this is what our type files look like. There's a schema, we generate TypeScript from them, and we export these types over here. We might modify them slightly using the utility methods I was talking about, but this is actually quite a nice way of defining your types. It's not that bad, I promise. I know YAML is one of those things that we shy away from, but yeah, it's all sorts of awesome. So those are the packages we use for that, by the way. So OpenAPI TypeScript. It's just a little compiler which is sitting inside my package.json over here. I just run npx open TypeScript against that and say, take those types and make a TypeScript file over there before I compile the project. Obviously, in our real package.jsons, we use a find command to find all our YAMLs, do them all in one fell swoop, and then copy them over to the output directory. And yes, what a time to be alive, really. It's what I am become YAML destroyer of code, yes, indeed. So anyway, real world example. Let's do some actual type gymnastics. That's what we came here for. 6 form builder. All right, cool. So this is an example taken directly from one of our code bases, and I've simplified it a lot because there's a lot of code in that file. But I thought it was quite an interesting example of how you can push quite a lot of logic into a type system. So we have these things which are reusable components that get registered in the system, and they contain a whole pile of information about how to run a specific node or unit of work inside a media workflow. Right? It could be pulling in multiple media nodes and doing things with overlays or whatever. It doesn't actually matter. And the very first thing that happens is you'd say, well, I've got configuration for that of this type. And given a configuration of that type, I'm going to initialize myself, and that's going to be a promise. Okay? And I'd use that over here. I'd use that by, I've got my config here, and I would say something along the lines of define component of that config there. And I've got a definition. And my definition needs to have a init function with my types config over here. And I'm just going to say console.log, do some stuff. And it needs to be an async function, or it's not going to work. Don't know why the editor doesn't do that for me, but whatever. Okay, cool. This is a standard pattern, right? Having some typed functions to call, which then set the types on the thing underneath them. So one thing we might do in this world, or we do, is for a given configuration record, we want to define a form. So telling the UI what fields we need and how we want to actually deal with them. And we want that form to have all the fields in it. So that needs to be, and we want to assert that at the type level, and we want that form to be appropriate for whatever's in the config record. So, for example, we can start off with saying we've got generic form hint, and it's going to be a text box, and the default value is going to be this thing over here. And of course, we might have validations such as well in this thing, but keeping it nice and simple. We have a text box with a default value. And we can say, okay, well, we have a config form hint. A form entry is going to consist of a form hint and a description of what actually that field is. And I'm going to say, actually, a config form is every key in the record config. I want to have an entry, config form entry, of the type of the field that's in that config row just there. Again, so made a whole new type over here. That's just, again, just cool stuff, really. And I'm going to put a form on this of type config form config. I'm going to go back to my other code over here. It's now going to be complaining because the property's missing. There we go. Property form's missing. I'm going to add that. Field is undefined by default. Put a record in there. Now it's going to complain because it's missing out all of the fields in the record. I can add those, and again, the TypeScript language server is quite handy here because it tells me, it puts the default values in for me. So I can say, cool, I've got a text box, this is the ID, it's a text box, the default value is going to be 13C7, whatever. My timeout, well, actually, here's a problem, my timeout is a number, not a string. So what the heck is the default value here? Like, it's, oh dear, well, that's just depressing, really. My default value doesn't match because it's not a number. But my text box is going to be dealing with strings. This is a stupid way of doing things. Let's not do that. So I'm going to undo that and go back over here. Turns out you can put conditionals in your types in TypeScript, and you do some really cool stuff. So what I might actually do is say, I've actually got a form hint for a string. I've got a form hint for a number, which could be a text box or it could be a numeric. Numeric? I don't think so. Or it could be a form hint for an array, at which point actually it's going to be a multi-select dropdown, right? And how do I do that? Well, what you do is copy and paste the code we've written already and dump it here. And then we stare at it a little bit to work out what on earth we've actually written. So a config form hint for a field, I can say, if the field extends string, then give me a config form hint for string. If the T field extends number, give me a config form hint for number. But if the T field extends any kind of array whatsoever, give me a config form hint for the array. And my types will now change depending on the types inside my fields over here. If I do add missing properties over here, so I've got a text box there, but if I go over here to my actual text entry, I'm allowed to use a text box or text area, because it's a string field. For my number field, I'm allowed to use a text box or a numeric. And automatically down here, drop-down has been selected by the language server because it knows that server URLs is an array, and that's the only thing it could possibly be. And again, that's been pushed into the type system. I've managed to construct a whole new type based off my config record, and that config record is going to assert all the fields exist, and all of the form hints are correct for the type that's in that thing over there. Now, in reality, the actual code we have is a lot more involved than that, because we have like 15 different kind of form possibilities inside the system, and we have custom fields and custom forms and whatever. Again, form engines are the kind of thing that we've all built at least 5 times in our career, or maybe 5 times a decade if we're unlucky. And again, TypeScript's been one of the nicest places to do this, because you can really start to push this kind of logic into the type system. So yeah, that's something that exists, which is nice. So you can build relatively complex types from other types by projecting them from one place to another. You can iterate through the fields in a record. You can recursively do that if you want to. So you can say, if I've got a record, go through its types and build nested objects and whatever. You can do some really funky stuff. Now, I'm not saying you should do some funky stuff, because I've seen some funky stuff, and wow, people do take this to the extreme level if you go on the internet. And you don't want to see type definitions that are 50 lines long with that many conditions in them. It's not pretty. And plus, if you get hit by a bus, someone else has to maintain that. So perhaps it's not always worth it. But for things like this, absolutely is. Being able to stick in conditionals into my effectively generic constraints is such a game changer. And it's really good for then building APIs of other people's defined types. So there's an example over here. It's all down to the implementer's types, and all I've done is given a surface area which to represent that, which is cool. And again, once you do this correctly, your language server starts writing code for you, which is just nice. And unlike ChatGPT, it's probably going to be correct. So it's got that going for it. Well, you can't screenshot that, can you? Because it's off the bottom. The slide deck was made for 1200 pixels, and we have 1080, unfortunately. So anyway, where did we end up? Well, I handed over the project to the other people who want to work on a UI, and that was 2 or 3 months ago, and I have not written any TypeScript since then, which is just nice. And I've had relatively little noise from the 4 or so developers working on that project. They've kept the types, they've kept the tests, they've kept the ESLint rules, and they've added new tests. And more importantly, the tests that are there have made sure that when they're making changes, things actually keep working, as do the types, which is nice. So I'm back to writing segfaults in C again, which is my happy place. It's what I enjoy doing on a daily basis, as I mentioned. And there's an old adage: if you don't want to be a UI developer, don't start a UI project. I was told 12 months ago, you're going to end up being the UI guy, and I'm really glad not to be. This talk, by the way, is because Raf just asked me to give a talk. I gave him a set of choices, and he said, do the TypeScript one. That's because 5 months ago, I was actually writing TypeScript. I've not written any in 2-3 months, which is just wonderful. Anyway, friends don't let friends use JS for anything more than trivial. I mean, that's just say no. As I say, I wrote my first iteration of this project in JS, and it was really fun. I really enjoyed myself. But I'm not a cowboy, I am a professional, so that is now yeeted and replaced with TypeScript. It was very fun. I understand the desire to have fun as developers, but sometimes you have to be professional. The only good ESLint configuration is when you'll learn to hate. If you can enforce it with type, you can't do this, exactly. TypeScript provides lots of tools for manipulating types, you should be using them. If you're just using TypeScript as JavaScript with some annotations, you're not using it to its full capability. There's so many cool things in there, and they're not too hard to use. I am genuinely quite impressed with it. Again, I imagine some people in the audience here, I'm teaching you to suck eggs, you've done this all already. But I just want to say, I like it. I'm positive about it, even though I'm not actively using it anymore. That's the end of my talk, and we're at 45 minutes, so I do have time for some questions if you want to, or I'll be hanging around and you can tell me I'm wrong later. So nice things said now, bad things afterwards, yes. Thank you very much.